Hi, I'm Kim Wines with Encore, and I'll be your moderator today. I want to welcome you to today's webinar on container security best practices that scale. We're going to be talking about how you can put in place best practices regardless of where you are in your container journey, if you're just at the beginning or you're already getting to scale, but you can put in best practices that will serve you well as you continue to increase your container adoption. So let's go ahead and do a few housekeeping items first. As we mentioned in the opening, if you can advance my slide there, Andre. Um, as we mentioned in the opening, we will have participant lines are muted. However, we will be taking questions at the end of the webinar, and you should have a questions panel on your GoToWebinar control panel where you can enter your questions at any point in time. So go ahead and put them in there, and then we will take as many as we can when we get to the end. Also, after the webinar, you will receive a follow-up email with a link to the recording for the webinar so you can rewatch or share with others in your org. And at the very end of the webinar, if you could just take a few seconds, there's a 3-question feedback survey just to give us feedback on what you thought of the webinar today. It'll take you about 5 seconds to fill out, or to suggest topics for future webinars. All right, so let's go on to our next slide. And just for those of you, most of you may know who Encore is, but I'm just going to give you the 30-second view if you don't. So Encore is a company that's helping organizations to secure their cloud-native software supply chain. So as you know, cloud-native is becoming the way most companies are developing applications, certainly greenfield applications, but even beginning to migrate and update existing applications. And as they do so, they're generally leveraging DevOps and DevSecOps processes. They're generally leveraging container technologies for development and deployment. And in doing so, there's really a need to embed continuous security and compliance checks into each step of the software development process. So starting from the very beginning all the way through to production, because by shifting left, so to speak, and starting earlier, it just increases security, but also lowers the time and cost of remediation. So that's all the commercial you'll get from us today. So let's go ahead and go through the agenda that we'll be covering. So we're going to be talking about best practices, and we've split them into these 5 areas around images for containers, policies, integration into your tool chains, SBOM, which stands for Software Bill of Materials, for those of you that may not be familiar with that acronym yet, and also organizational best practices. And then we'll follow that up with a Q&A. So why don't we, before we get started, if you want to move on to our next slide there, Andre, we're going to do a few polling questions. This is really helpful for you guys to get a sense of the rest of the audience and also for us to get a sense of you. And so the first polling question is really just about what is the adoption of containers within your organization. So just select the one that's most applicable if you're just getting started, if you've got maybe some adoption of containers, significant, mostly all or all applications using containers. So let me give you just a couple of seconds to make your selection because I want as many of you to be able to vote as possible. And 2 more seconds. And then we're going to go ahead and we're going to close the poll here. All right, so we'll close that. I'm going to share the results with you. So you can see 39% of you are just getting started. So that's great. That means that you're going to put in place the right processes and best practices so that as you grow and as you increase container adoption, you can scale. And then another 30% are at the some adoption level. And then we've got quite a number of you also, mostly all or all applications using containers. So you guys are already potentially scaling. And so hopefully we'll have some good tips for you as well. All right, so let's go ahead and go to the second polling question, which is, whoops, sorry, hide that. How much will your use of containers change in the next 24 months? So would you say it's going to increase significantly, increase somewhat, stay about the same, decrease somewhat, or decrease significantly? And I'm going to be really surprised if anybody picks decrease significantly, but we'll see. Maybe we'll have an outlier there. All right, you got a few more seconds there to finish up. All right, and we'll go ahead and close the poll, and I'm going to share the results with you. And probably not surprisingly, most of you are in the increase significantly or somewhat phase. And then I guess some of you that are staying about the same are the ones that are already using containers pretty heavily. All right, one final polling question. And this is really asking you about some of the best practices that you already have in place. And here you can pick more than one, so you can check all that apply. So whether you're using, private registry or repo for vetted images, whether you're scanning at more than one stage in the development process, do you have some type of policy-based controls to help you control false positives come through when you're scanning and doing your security checks? Whether you're leveraging an Sbomb at all, a software bill of materials in any way. And another trend is people putting security champions embedded in the development team. So having a specific developer identified as a security champion. So whether you're implementing that. I'll give you a few seconds because there's a lot of checks to make. All right, so let's go ahead and close the poll, and I'll share the results back with you. So a majority of you are using private registries and repos for vetted images, so that's great. We'll talk a little bit more in some details about that. Maybe you'll get some additional tips on how to go about that. Just under half of you are scanning at multiple stages in the development process. And then in a fifth or a quarter of you are doing these other items that we've listed here. So that's great. Thank you for sharing that information. So with that, I want to go ahead and introduce our speakers for today and hand it off to them. So the first speaker that we're going to have, if you want to take us to our next slide, is Andre Neuville, who's a DevSecOps engineer here at Encore and has been working with many customers who are trying to embed security into their container processes, and Neil Levine, who's our VP of Product. So I'm going to start by handing it off to Andre. So Andre, if you want to show us your lovely image by turning on your webcam, and then I'll turn it over to you.
Thanks, Kim. We'll go ahead and get started. So the first section here is focused around image best practices. So one of the quickest ways that you can improve security and address flaws in containerized applications is to implement a set of guardrails around your images. So the first slide here highlights essentially focusing on some quick wins. So this can be applicable to organizations of all sizes, but is especially true for small development teams and organizations that may not have the resources to vet and manage their own image repository. When you decide on a base image to use as a foundation for your containers, you indirectly take on all the risk that comes with it. Next, as a team or organization, standardize around the images that you'll use to build your applications. Try to make the images as small as possible while still being able to run your application without issues. This can greatly reduce build times and the number of vulnerabilities present in your container. Just be mindful that this does not limit exposure to the future vulnerabilities that may come along during the lifespan of your application. And finally, avoid using generic tags such as latest in image builds. Tags are not immutable, as maintainers can publish multiple images against the same tag. This means that the actual contents in your image might change between builds without your knowledge. Also, use explicit versions in your build contents, and if you really want to be certain about the contents in the image, make use of image digests, which is a hash generated from an image build that also serves as a unique identifier for each image. Having some trouble here. There we go. Looks like one of the images didn't come up. So the next slide is focused around education for development teams. So once you've implemented a set of standards around the what, you can start to address the how with respect to your container images. Specifically, you want to make sure you educate developers on common best practices to consider when building a container image. Images often contain artifacts that are only required during build time. These artifacts, which include tools, libraries, or other dependencies needed to build your application, can greatly increase the size of the image as well as the attack surface. Multi-stage builds are a way of structuring your build files such that the end result is a smaller, more compact image. This has the added benefit of reducing the security footprint of the image, as any unnecessary components are thereby removed from the final product. Secondly, one of the inherent advantages of containers is that they are lightweight, portable packages of software. As such, you should try to avoid using a single container to run multiple packages of software. This adds complexity to the container and can lead to unexpected problems in production. And finally, avoid hard coding any sensitive information, such as secrets or API keys, into the image itself. The third slide focuses around building a walled garden of content. So some of you in the poll mentioned that you're already doing this with regards to using private registries and repositories. So I'm sure a lot of the audience is familiar with some of these suggestions. But if your organization maintains a private registry of approved images, just make sure that you have complete visibility of what is being stored. Developers may look to leverage open source content with the set of tools and components that they need. And if not gated, they may push images into the private registry for easy access later on. This can introduce vulnerabilities into your environment and cause your image registry to grow out of hand quickly. The recent supply chain attack affecting major tech companies, including Microsoft, Apple, and Tesla, serves as an example of this, as vulnerabilities were introduced through dependency squatting in open source content, which was hosted in public software repositories. Implement processes around what can be pushed to your image registry and how it should be managed. For example, restricting image pushes to the registry unless it's actually coming from the pipeline. Make sure you identify open source content that you want to bring into your environment, and only once it's vetted, ensure that your developers can only use those private hosted images to build their container applications. And even once you have those good image building practices set in place, you should still continue to evaluate your images and ensure they are not shipped with any unnecessary tools. Utilities such as curl or netcat, for example, may be useful for testing purposes, but those should not be included in the final product. So the next section focuses on strategies for integrating policy best practices into the supply chain. So the first slide here focuses on understanding that requirements may vary between projects and teams. Your policies should also be reflective of this. Teams may have specific workflows around how they document and address issues. Instead of evaluating your containers for compliance against organizational policies and industry best practices at the certification phase of your workflow, try to embed these policies and best practices into the development team's workflow. And also performing validation up front can facilitate quicker feedback and improve development velocity. So the next slide focuses on defining an organization-wide vulnerability policy when it comes to managing false positives. There's nothing worse than providing developers a list of vulnerabilities without direction on prioritization or guidance on how to resolve them. This can lead to frustration for developers and friction between them and security teams. So when evaluating vulnerabilities reported by your scanner, take advantage of other pieces of metadata, such as the CVSS score and any reported fixes to help with prioritization. Also create timed exclusion lists, which can avoid derailing development timelines while teams work on addressing reported issues. To help cut down on noise, pay attention to what OS vendors report about a particular CVE versus the information that you might find from a third-party vendor. Typically, the software maintainer will have more coherent feedback on a CVE as they reinforce reported information with internal research on the reported issues. A common example of this is where is applicable in OS vulnerabilities, which, for example, might be reported directly from Red Hat versus CVE data about the same vulnerabilities reported through a vulnerability database such as NVD. And this third slide focuses on validating container content as the final complete artifact. So your container analysis should complement information gathered from other tools, such as source code analysis tool, rather than supersede it. Take advantage of policy enforcement in your container scanning tool to amplify feedback on where issues may have appeared in the pipeline, so that you're not waiting until pre-production to validate your containers for compliance. And with that, I'll turn it over to Neil. Neil will be focusing on integration best practices.
Thank you very much, Andre. Just take over the presenter role.
I'm giving you presenter there, Neil.
Thank you very much. There we go. Excellent. Okay, thank you very much. So I'm going to be covering 3 more areas, which is around integration best practices, how to use software bill of materials, and some organizational best practices. So let's focus on integration best practices first, which sort of relates to how you should be using container security tools in general. So it's pretty common to add container security checks at a single point. Most teams or organizations, they come in with a specific view of trying to plug it into a registry maybe to get going. But actually a defense in depth can actually, get you a better return on investment from your security tooling, and give you, a much wider coverage of where issues may be coming in. So critically, whilst most DevOps teams are sort of aiming for a single pipeline, everything flowing nicely, automated in an automated fashion from the source code all the way up to runtime, you have to recognize that containers can bypass this. Users can find ways to either upload things directly to the registry, or in some instances even directly into, say, your Kubernetes environment. So again, it's defense in depth, where you want to get the container scanning at as many stages as possible. Even if you're confident about your security pipeline, try and get it done as many places as possible. Now, there's not a huge penalty to doing this. Containers have a unique ID, so it means that if you are scanning at multiple stages and that container's been seen before, it won't get scanned again. The results, or there's no penalty, there's no time. You've got the results that get shown already. If for some reason the container ID does change, then it will trigger a scan. But the fact that it's changed is, maybe an indication of some sort of problem. Finally, if you do these scans at multiple stages, then it gives you sort of an ability to start looking at drift. And if you say content changing, either in the metadata or more typically in the core data of the container itself, then this is an indication that there's a problem. So as SolarWinds has made everybody very aware, actually how this content is being managed and whether it's been backdoored throughout the process is now front and center of people's minds. So again, scan at as many places as you can. Don't just assume because you're doing it at registry, you're catching everything there. Don't assume you're doing it at runtime through maybe an admission controller or something like that. You're catching everything there either. So use multiple stages. Having said that, if you can only scan at one place because of operational reasons or what have you, then the place that you really want to focus on is the CI/CD stage if possible. So it's pretty common to sort of do the registry as the first place that you go in, because typically it's the easiest way to integrate for, say, a product security team approaching an operational environment. You just have to effectively ask for a username and password to get that, or a token to get access to the registry. But CI/CD really gives you a lot more benefits, and we see that organizations that go in and manage to get security scanning integrated at that stage tend to sort of catch more things and are able to manage the situation slightly better. So importantly, if you get it at CI/CD stage, you can scan before it goes to the registry and gain access to other components which can also influence the overall sort of security results. So importantly, things like the Docker file, which itself, you don't need to use that in a runtime, but can potentially inject security vulnerabilities or open ports, or show that certain files are getting installed. So other build artifacts like that, you're going to get access to them at CI/CD, give you a much better view of the overall security than just a sort of a static analysis of the container contents itself. Now, note that quite a few technologies, available from the public cloud vendors and as well as us and others. We'll talk about CI/CD scanning, but there are some nuances to it, which is that some of those are actually really just doing registry scanning, but the registry scanning is triggered from CI/CD. So if you're getting a build, pushing it to a registry, then you're activating a scan as part of your CI job. So be aware that that doesn't necessarily give you some of the sort of benefits from a native CI/CD scan where everything's kept inside the CI/CD platform. You don't have large images being transferred or unnecessary things going into your registry. So just pay attention to the details. But if you can do CI/CD scanning, you're going to get the top of the tree, as it were, to start seeing where things then change after you've done that first scan. So if you are looking at the registry itself, and maybe that's the only place you can do the scanning for sort of security or authentication reasons, it can be a little bit of a Wild West when it comes to the content in registries. And we've seen a huge variety from sort of people doing one repository with one tag, which gets every commit, the latest tag, so to speak, or hundreds of repos spanning multiple versions, or one commit creating a tag every time. So there's lots of different ways of managing the content, but you do need to sort of think about the security strategy as it relates to the architecture of that content. So first of all, not everything necessarily has to be scanned or scanned in the same way. So there is, there are different ways of doing security scanning. Some will do a very light touch vulnerability scan, or maybe just a license check, which is something for developers to let them know if they're using, say, GPL software. Whereas you may want to do a complete scan around the entirety of the contents and all the metadata and also some other things like secrets. So separate out and realize that maybe one set of repos needs a light scan, another needs a full scan. You'll save yourself a lot of time and resource management. The other issue is that when you get an overflowing registry where everything's being stored and it's all in a single registry, and you can't sort of distinguish between maybe production or sort of staged or developing testing content, it kind of makes it hard to know where to focus your efforts if you're getting a lot of security vulnerabilities and reports out of it. So ideally you can start with a runtime inventory and use that to sort of drive the triage processes. But even just knowing that when a vulnerability comes up, it's on a registry which is exclusively used as a staging for production content, or maybe content which is publicly exposed on the internet, that can just help you with your triaging sort of efficiency. So again, think about content as it comes to your workflows and your likely response that you're going to make to vulnerabilities. Think about these areas. However, additional metadata or structure can generally give you just good proactive stance with as a security team. And the side benefits, sometimes it can really help you see where problems are endemic or really sort of common to specific teams or projects or certain applications. So you can get some interesting sort of data back where you see a lot of results coming back from certain repos or tags. Okay, so that covered some of the integration best practices in terms of how you think about using your container security software. So one of the things that we like to evangelize here at Anchor is around software bills and materials, or Sbombs as they're colloquially called. And I think as a few of you had mentioned in the poll that you were using those. And the key insight that we like to sort of make sure people get is that the software bill of materials is somewhat that sort of bridge between maybe the traditional source code scanning that many companies have been doing for many years, checking developers' dependencies and maybe bugs that they have in their code, and then all the way on the runtime where you're doing your live operational sort of detection of strange behaviors and sort of network behavior which shouldn't be happening. So the SBOM in a way is kind of like the glue to sort of tell you how is content changing from the time the developer's making a commit to when the application is actually being run. And as we've noted a few times, containers evolve, they change over time as they're going through your software pipeline. And so the SBOM gives you insight into what is changing and why things came in which weren't there at source, or sometimes even they're not there at runtime, they get pulled out at the end. And they can also explain, so the why and the when and the who of, what's changing with the content. So they're a real asset, and particularly when you're trying to debug or diagnose, maybe a security alert and see where it came from. The SBOM can actually be additional insight. So rather than just saying, okay, this package has got a vulnerability, let's just upgrade it, to sort of understand, well, who added that package? When did it get added? Was it deliberately selected? Was it brought in as a dependency? Was it actually added manually? Was unnecessarily added to a base image? So it can really help you with that diagnostic process. It can also help with impact analysis if you sort of identify a problematic file, not even a package. So a lot of vulnerability information is very sort of package management centric and tells you about sort of things your operating system or your language environment have added. But if it's a problematic file which is causing an issue, you can take that that file name and the version and ask, does this file exist in any other container? And so it will give you that insight for impact analysis to go back and sort of play forward from your diagnosis where else you may be impacted because of a corrupted file or something that was, got a bad configuration to it or so on. So it gets you out of a package view and into a file view, which can be very useful. So anyway, in summary, use your Sbombs to try and help drive your diagnostic process, help you detect where things are changing and where the containers are evolving during the pipeline. However, if you are going to try and use Sbombs, and this kind of also impacts vulnerability analysis, be aware that the quality of the analysis is only as good as the data coming in. So there's a sort of garbage in, garbage out aspect to Sbombs. They can only be as effective as the accuracy of the metadata that's often associated with both the files and the packages installed on the container. So it's pretty common for organizations to create their own packages, especially if you're using Java, which is a big culprit we see in this area, where you're creating your own jars, with your applications or components in your infrastructure. There's a tendency to sort of forget about the metadata. It's not enforced in any way to sort of you have to fill it in and keep it up to date. It's somewhat arbitrary. So if that metadata is not accurate, then the SBOM is not going to be accurate. And actually, at the end of the day, the vulnerability assessment will not be accurate either, because we're then reporting on the wrong piece of information, specifically file versions. So just pay attention to how developers are creating your own custom packages and what metadata they're setting in them. And this is a good example of where a true DevSecOps process where security involved early can sort of help educate the developers as they're creating these things. So you can say, look, it means that keep it up to date. When we get problems, we can really be specific about versions and which files are causing our problems, and not distract you with unnecessary false positives. Okay, so a little bit about Sbombs. So in the final section, we're just going to cover some sort of slightly more organizational areas, a little bit less about the technology, more about the approach and processes that we sort of see work and don't work. So the first one is around, and these may sound a little bit platitudinous, but we'll give you some hopefully a bit more detail here, which is reducing friction for the developer here. So there's this cliche that developers are the new kingmakers, and they have all the power and the decision making, but like kings, they can often ignore well-intentioned advice and all things that make their lives uncomfortable here. So we've definitely seen there's some techniques which work around really trying to get your developers involved in the security process. So the first one is that if you are going to give them information, you want to get it back to them as close to the commit time as possible. So the moment that they add it, they sort of commit the line of code. If there is a security issue, get the result back in a timely fashion. So just like a failed build, typically developers respond to that very quickly, or or bugs which cause major regressions. The closer that is to when they created a problem, the better. So getting bugs later is, can cause context switch issues where they're working on a new piece of code, they're working on another part of the application, going back to an older piece, kind of like they'll put it off whilst they're working on a current thing. So again, think about the time, that sort of mean time to alerting of developers. And it, again, may sound obvious, but keeping all the information in existing tools and platforms they use is essential. So a lot of security scanning products will generate, custom reports in PDFs and, or JSON or CSV or what have you. But really, if you can get the information in a way that developers are used to interacting with in their ticketing systems, whether that's GitHub, GitLab, Jira, what have you, try and format it in a way that is natural to those environments, and avoid using large attachments if you can. So a lot of modern ticketing systems will present natively security information, so try and use those where possible. But don't expect developers to sort of come over to custom interfaces or interact with sort of arbitrary lumps of attachments which you put in there. Developers tend to homestead their environments within these ticketing systems. You really want to take advantage of that where possible. And lastly, the content does actually matter about what you're generating for them. So developers are not security experts. They don't really want to understand maybe the nuances or diagnose or research the specifics. They just want to know, look, what is the problem? What do I need to fix? So the more specific the information, the better. So here you can see we're trying to give them really detailed information around, replace this package, we're not using this, upgrade to this version. If you can get that in Slack, if you get it in a Jira ticket, give it in a way that makes it clear what the actual action is. And then finally, this is probably one of the biggest things that we hear with security teams in particular is help me scale. We don't have the resources to handle the growth in developer activity or application development, in this cloud native way. So yes, security teams are never going to grow at the same speed as developer teams, and budget will never sort of magically fix this. So as I mentioned before, DevSecOps is, it's a marketing term. It's sort of a little bit imprecise, but a key aspect is obviously improving the velocity and the security of your software development. But just like the original DevOps approach, it's also about getting those two teams working early. So even if you don't have a large team, really trying to work on being added into a project at the beginning of a process or the beginning of a sort of a software development project is absolutely invaluable, and will ultimately lead to better decisions being made around content or architectures and policies. So as we noted earlier, just telling people keep your package metadata up to date, that's going to really help with the security later. It's the kind of thing that you can realize if it's a Java application they're building, give them that insight. So especially when it comes to the design of the pipeline, as we mentioned, at the beginning of the session here, ensuring that the tools are integrated in the right way, at the right place. If you can get it involved in multiple areas, that's really a sort of should be the collaboration between certainly the ops side and the security side. The second thing comes or relates to policies. So as Andre highlighted, policies are a great way of controlling, false positives, making sure that you're only focusing on the right things here. But policies will need to change. They are going to evolve over time. It's no longer the case that a policy is set for the year. It's just constantly evolving as new vulnerabilities are discovered or as sort of new issues are sort of highlighted in public breaches. So we've seen, yes, you'll have baseline policies that you will have hopefully across multiple teams, with individual teams having their own sort of customizations. But actually ensuring there's a simple way to keep those things updated is really important. So this is a good example of where Git can really help. Storing of policies in Git will give developers and operations teams a sort of a tool which is familiar to them for submitting requests and tracking whether they've been implemented. And it also gives security teams a nice audit trail and a commit log, and you can obviously roll back and other such things. So being flexible with the policies, trying to understand how, thinking about your policy workflows again at the beginning of a container security architecture is really important. And last point here, and Gartner have noted this as well now, that given the lack of scalability around security resources, trying to identify security champions in the sort of certainly in the developer or in the operations team can be incredibly effective, where this will allow you to sort of look for that developer who is very attuned to security issues, maybe helping them act as a triager or a first line of defense against issues as they come up before they hit you as a security organization. So they can help you sort of from being overwhelmed, allow you to sort of get insight around what's working and not working, around policies and other areas. So working with them means, education, but also including them in the policy decisions and the reviews. So look to see if you can enable security champions to sort of lighten the load. And with that, we come to the Q&A. So I'll hand it back over to Kim.
Thanks, Neil. All right, everybody, if you have any questions, I've got a couple that have already come in the questions panel, but feel free to add yours. And if I can get both Neil and Andre to join us back on webcam so we can see you as we talk with you. So I'm going to start off with a question for Neil. And the question is, does Anchor provide a list of supported/recommended Kubernetes Git providers, Kubernetes/Git providers?
So if by recommended, we certainly have supported technologies. So on the Kubernetes side, we support all of the major public clouds, EKS and GKE and so on, as well as OpenShift and Rancher, the more self-managed environments. We don't recommend one over the other. They're all, that's one of the advantages of Kubernetes, is that it's a fairly standardized environment, and so it tends to be the surrounding services which customers need to sort of choose what they want. So we don't recommend any. Similarly with Git, we partner with GitHub, GitLab. We're sort of fairly agnostic and are not prescriptive about any of the technologies, and recognize that companies often change or have multiple environments, and so we don't prioritize one over another. But when it comes to sort of best practices and scaling, there's not much to choose from. I don't, all of these providers are designed to scale up. The only comment of note is that, and doesn't help reduce it massively, but pretty much all of these vendors have now implemented some sort of security view around the pipeline and around the scanning information. So again, sort of looking at those and deciding which tool you think presents the information in the best way for you as a security team, or that will give insight to your developers, that might help tip the balance in one way or another.
All right, great. And in addition to, you mentioned GitLab, GitHub, we also have CloudBees as a partner. We work with open source CI/CD tools as well, so pretty much the gamut.
That's right, yeah.
A follow-up was, can Anchor policies be implemented as an audit or deny type?
Can Anchor policies be audited as a, I'm not sure what the, well, maybe I'll answer the question with a little bit of a technical explanation here. So Anchor policies are very simply just as a JSON document, which has a list of sort of rules about, do you want to stop or warn on certain criteria, and there's a number of triggers that can be implemented for, as Andre said, pretty much everything in the CVEs from the vulnerability information, but we do a whole lot more, allow these packages, don't allow these packages, or these images, or don't allow these text files to exist. There's almost an infinite array of things you can customize with our policy engine to sort of like block the deployment or the build of an image. So yes, all of that is effectively audited. So when an image gets processed with a policy or get a policy result, giving you the final results, that is archived in the system, and you can see that associated with the particular image ID. So it never changes as long as that image is in the system. You've got that policy result, and you can give you that full audit of, at a point in time, whether an image passed or failed.
Great. Another question for you, Neil. Can policies and scan results be copied from one Anchor instance to another Anchor instance on another network?
So the policies absolutely can be. The policies, as I mentioned, are just a relatively straightforward JSON document, and yes, those can absolutely be sort of copied or syndicated across multiple instances. The results of a scan can be as well. It's all stored in a database. Those database contents can be effectively backed up and restored to another instance. But there's no sort of federation, as it were. There's no sort of sharing of the results amongst different instances to, for example, if an image has been scanned once in one instance, ensure it's not scanned in another. So you can move the entire data set, but there's no sort of sharding or federated kind of aspect of the technology.
Okay, perfect. All right, I think that's it for the questions. So thank you to our speakers, to Andre and Neil. Look for an email in your inbox with the recording, and please take the quick survey afterwards because we'd love to get your feedback.